Hey guys, it's Wade again with another mill CNC project update. I really didn't expect to be doing another video so quickly after the last one, but I've actually upgraded and installed a number of things, and I wanted to cover them. As a precursor, part of it, I would chalk it up to what I'll call best practices, and that is on these stepper motor drivers, these wire connections right here that are the interface that go over to this top line connection board to the Acorn CNC board. Technically, these connections right here are for AC servo motors, which these are not. And so that's why I'm saying for best practices, you're supposed to hook up these stepper motors, which are closed loop stepper motors. They're kind of lead shine knockoffs, but for these type of stepper motors, they should be connected to this DB25 connector here. And that specifically is for 5-volt logic inputs, or interface, I should say, to these stepper motor drivers for both step and direction. And speaking of step and direction, that's 2 of the 3 signals that you can get. I've actually disconnected these 3 wires right here earlier to test out what's called enable, and tested out the drives with these disconnected to show that I don't actually need that signal, which that signal does not come across on this DB25 connector. Now, the reason why I'm starting out the video is to show you the DB or D sub connector that I made up. Now, a lot of people buy one where you crack it open and then you basically have these type of wiring connector inputs in there. I am building an airplane, so I do have aircraft grade material, so I just grabbed a DB25. Now, another thing that I've been seeing on the forums is that these wires that go from the Acorn to the stepper motor drivers should be shielded wires. So with that, I am actually using, again, aircraft grade wire, and inside here, these pins, the shielding on the wire is all connected together, and then there's a final pin right here that goes to the common. There's a difference, of course, between ground and common, but I figured that would at least give it some shielding properties. So, but these are shielded cables. Here's the other ends that will go into the stepper motor drivers. Now, I show you that, and I'll actually show you the new Acorn CNC board. The new board is all cleaned up on this edge specifically, where there's an interface right here with this ribbon cable connector that goes over to this new 8 relay breakout board. Even the board, as far as the relay board's been cleaned up a little bit. It doesn't have the gaudy green big large connectors right there. As I mentioned in the last video, it may be hard to see, but there's actually rows all the way around, even down this side here for the relays. These are all LEDs that will light up different colors, red or green, depending on the state of the actual connection point. And one thing you'll note, the onboard relays right here, which I'm not even sure are interfacing with this. I'll have to test it out because, again, this is the new board. But I'm actually using this onboard relay right here for a new connection that I'll discuss in a little bit. That is not on the new board. So, again, I wanted to show you the new Acorn board. This will go into the lathe CNC controller. And then really what I also wanted to show you was there's the DB25 connector. And then this will go right in here, and that's how that will connect up on the Acorn CNC side. Now, I do want to mention one other thing. In all my research, if you've seen Franco on YouTube, he's just got a ton of information and a ton of knowledge, and I want to do a big shout out to him. Now, this is in no way, shape, or form dogging him out. This is kind of against Centroid CNC, and I love the Acorn system, but when you hook these up, and I've seen on just about all his videos, this top line board right here, these connectors, is where he hooks up to his axes for his stepper motor drivers, they work. Just like mine are working right now. But apparently this is a 24-volt AC system that's pushing into here. And then you have, this is actually 5 volts coming from the power supply. So again, I'm going to chalk this up pretty much for best practices. Being prior or retired military, I will say that when you look in a tech manual or tech order in the military, it pretty much tells you specifically why you shouldn't do something, how you're going to let all the smoke out or something. Besides just saying that this is 24-volt AC, this is working, and then over here it's saying that this is for 5-volt logic. I'll just go back and I'll say this is for best practices. I'm going to try this out, and if it optimizes the process and makes things smoother with the stepper motors, okay, great. But beyond that, say I'm doing best practices. Okay, so I did get this cable installed, the DB25 connector on the Acorn board, and then this is powering and interfacing. I shouldn't say powering, I should say interfacing with the X, Y, and Z stepper motor drivers with the Acorn board through shielded wiring. One point of note is that I had to invert every single one of these drives. I will say that this looks a lot cleaner. I can't obviously tell any difference in how the drives work. With that, I'll show you that I did an upgrade to mill CNC 12 Pro. I was able to then get the MPG4 wireless pendant running. So I'm going to try to, even though I have my camera on wide angle, I'm going to give you a little demonstration here. So I'm going to go to the X-axis right there. Let's try to go off to the side here so you can see this, and you can see the X-axis at the same time. I've got it on 10 for speed. So there's that. Let's go to Y. See that moving a little bit. And I'm just going to show you the axes. Of course, there's a bunch more that you can do on this. Let's go on Z. We'll bring it down just a hair. So the MPG4 pendant is operational, and of course I'll tweak it and integrate it more in my usage, but I just wanted to show you that. Okay, another quick update I did was I updated the park macro so that I could get the X-axis and the table, instead of having it parked all the way over hanging off to the left, I figured I would have it a little bit, about a third of the way. Then I have, of course, the weight of the motor, so I figured that would be pretty good. So I'm going to go ahead and hit park right now. See the headstock moving up, the Z-axis, then the Y-axis. So the Z-axis, it's about 0.3 of an inch away. Same, actually the Y-axis is about 1.2, 1.4 inches, so that I don't have quite the overhang here when the machine is in rest. And then again, just what I was just telling you. So that's the updated park feature. The next very significant update that I did, which I was not planning on updating this so soon, but I realized that I could go ahead and get this capability as far as controlling the mill spindle speed and direction. And the only thing that I'm lacking is the feedback loop to really dial in what my RPM numbers are, and that's through this encoder right here. I'll have to hook that up later on. But again, this will give me the feedback loop that will really tell me what the spindle speed is so that it can adjust it. So right now, I'm typically running about anywhere from 30 to up a little over 100 RPM off at any given time when I command an RPM speed from Acorn software. But I wired up the KBSI 240D. I went up here to the power supply and connected into the 120 volt. There is a connection from the KBSI board down to the Acorn board. So the Acorn board spits out 0 to 10 volts, and it goes into this connection here. what the KBSI does, and you set your minimum and the maximum voltage, and my minimum is 0, which equates to 0 RPM. My maximum is just a hair over 4.8 volts, because you're looking for 0 to 5 volts and an input to go to the mill, to its spindle speed controller. So basically you're taking control of the mill, or you're sending the signals to the mill spindle speed controller. And again, this is just for speed, and that's through these two wires over here that actually go through, and I know it's kind of hard to see, but especially right up here, you can see one brown wire and one white wire, and those are the new connections that I've made between the Acorn CNC control box and the mill control box, and I'll show you all that in just a second. The other significant connections that I've made are on the 8 relay outbreak board, and it's relay number 3 and relay number 4, and these are the part of the system over here that actually control the forward and reverse of the mill spindle. So you have relay number 3 again, and then those wires go over to the mill, and of course the same with relay number 4, which is for reverse. And so these have been configured within Acorn CNC, the software to control the spindle in the forward and reverse. And then this white and this red wire right there are part of what is a output. It's called the no fault out, and I'll explain that in just a little bit. So I want to take a break real quickly to go back to my hack diagram. So this is all the new machinations I've just done on both the mill and the Acorn CNC control box. So I showed you this earlier. This is where I took the X, Y, and Z connections to these motor drivers, and I moved it over to this DB25. Then what I just described over here is output 3 and output 4, and those actual outputs are spin forward and spin reverse for the spindle. Right here, I also earlier just described the spindle control interface. In the last video I said it was an output, it's actually, or an input, it's actually an output. And again, it's 0 to 10 volts to the KBSI 240D, which then translates that into 0 to 4.8 volts. So here again, the KBSI 240D connection to the mill. I went over the MPG pendant just a little earlier. Part of the wires in those two wires that go to the mill, I have the e-stop, which is right here next to the computer, and then there's an e-stop on the mill, and I have an asterisk here because right now through this no fault out, and again I'll explain it in just a minute, but if I hit the e-stop on that's right next to the computer for the Acorn CNC, it will actually shut the mill down, and I'll show you that in a minute. I've had to order another e-stop because I needed 2 separate normally closed circuits, because there's a little bit of power. I don't know where it's coming from, but there's a little bit of residual power that's coming through. Just to be safe, I ordered a 2-circuit e-stop. But what that will do is through this no fault out that goes to the mill, that runs via the onboard relay number 2 on the Acorn CNC board, it will actually, either way, whatever e-stop I hit, it will shut down both the mill and the Acorn CNC commands and all the functions completely across the board. So that right there, everything in blue, and the black MPG pendant, that's all new within the last couple days within my configuration for Acorn CNC and the mill. Okay, I want to cover this no fault out feature. I'll note starting out that you'll see that there's no RPM control for the spindle now on the mill. There's also no forward or reverse button. and I've completely taken out the quill DRO and all the features for that. I'm not going to be moving the spindle up and down. So this is where I'll throw out a caveat. Don't do this at home. This is what I did, but for safety reasons, don't do this. But when you get the PM30, it originally comes with a chip guard, and this chip guard, when it's open in this pocket right here, is a micro switch. So the chip guard has to be closed, therefore the microchip is closed, the circuit's closed, and it allows this to run. When I took this chip guard out, I simply took the two wires and I connected them together. Well, the no fault out, what that does, there's actually wires running via the two cables and connects to each lead that I cut for this micro switch, and it runs it through that onboard relay on the normally open and the common circuit. So what happens is when you fire up Acorn CNC, it closes that circuit, and normally in the unpowered state, it's in the normally open. Now most of your e-stop button is going to be in the normally closed circuit in case it gets cut, and then it'll open up. But what happens then, if there's any fault in the system, it will open that relay circuit. It'll just be just like if you open this chip guard, and the relay keeps it closed, just like the chip guard being closed. It's the same exact wiring, but then it just goes into the control box now. But then if there's any fault, it opens that and it shuts this down. And I'm going to show you that right now. I'm going to power up the mill. I'm going to take the e-stop button, which would normally just be for the Acorn CNC control box and that system, and I'm going to hit it. See how that shuts that down? Now, it doesn't do it yet in the reverse, and that's why I have a new e-stop button, because I didn't know exactly what model that was. So if I reset this, the Acorn is good to go, but I have to power this on again. And then again, I'll show it to you one more time. This is connected to the Acorn board, and it shuts that down through that no fault output via the relay 2 that's actually on the Acorn board. So that is the no fault out feature. Okay, I'm going to finish up this last segment. I'm going to be holding the computer in my hand, so pardon any jittery computer action. But all right, so I'm going to actually show you how I control the spindle. I've got the mill powered up. So right now you can see I've got about 147 RPM commanded on there. This M3 is forward, the M4 is reverse. That just happens to coincide with the relays. So I'm going to hit cycle start. And you can see, now this says 147 right here. Again, I have no feedback through an encoder, so I'm getting 94 on the readout on the mill. And I'll be honest with you, when you try to dial in a very specific RPM on the mill, you just don't get it as well. It jumps around from anywhere from 10, 20 to 60 to 70 RPMs off anyway. So that's where that spindle encoder will come into play. All right, I'm going to increase this. Try to see if I can get both in the shot at the same time. So we're at 1430 there. And again, 1590 there. So not super critical. I'll go even a little higher. So there we've got 2280, 2293, and we're showing 2050 here. So that's quite a bit off. Sometimes it's spot on, and sometimes it's quite a bit off. Okay, I'm going to go all the way. That's 2950 that we're showing right there, and 2973.83, so it's about 30 off. Okay, so I'm going to bring this down. Got it 442 here, 423 up there. I'm going to stop this. Now we're going to go in reverse. I'll just show you that really quickly. And we'll fire this thing up. I don't know if you can tell, but the spindle is definitely going in reverse. So, as far as my CNC project and the capability, currently, as you can see, I've been able to control, for the most part, the RPM, the speed, and the direction of the spindle on the mill via the Acorn CNC program to the computer. So, that's it. Thanks for watching.